This section introduces the core problem. We're using Gaussian process regression, GPR, with a radial basis function, RBF, kernel, and its overfitting. The goal is to identify adjustments to fix this overfitting. The RBF kernel is a mathematical function that measures similarity between data points, and we'll see how adjusting it affects the model's behavior. Here, the problem is precisely stated. We are using sklearn, a popular machine learning library in Python, and we are working with GPR. I see that GPR uses an RBF kernel, and the key point is that the model is overfitting the training data. The RBF kernel's formula is explained to show how it works by measuring the distance between data points. It uses a parameter, gamma, that controls this distance calculation. This option suggests changing the parameter gamma. A smaller gamma means the model will look at bigger differences between data points. The model will be less sensitive to small changes and will create a smoother model, which usually leads to better generalization and prevents overfitting. This option proposes adding noise to the kernel. This helps to deal with noise in the training data. By explicitly accounting for noise, the model won't overfit to it, leading to better performance on new data. Switching kernels is another strategy. A linear kernel is a much simpler type of kernel and will be less prone to overfitting. Using a simpler kernel makes sense when the current kernel is causing overfitting. This section outlines a strategy to solve the overfitting problem. I will carefully follow each step. This explains the role of gamma, in the RBF kernel. I learned that a larger gamma means the model is very sensitive to small changes in the data, causing more complexity and a higher chance of overfitting. A smaller gamma makes it less sensitive to these changes, leading to a simpler and smoother model, thus preventing overfitting. I see overfitting, which means my model is too complex. To fix this, I need a simpler model. Decreasing gamma, in the RBF kernel makes the model less sensitive to small input changes. This creates a smoother, simpler model that generalizes better to unseen data. Think of it like smoothing out a really bumpy road. It makes the ride smoother and more predictable. Noisy data is like adding random bumps in the road. Adding a noise component to the kernel allows for these bumps and prevents the model from trying to perfectly match the noise itself, preventing overfitting. It makes the model more robust to uncertainties in the data. Switching to a simpler kernel, like a linear kernel, is another way to reduce the complexity of my model. It is like changing the shape of my model from a complex curve to a straight line and less prone to overfitting. This makes my model much more effective. I'm tackling a problem where Gaussian process regression, GPR, using a radial basis function, RBF, kernel, is overfitting my training data. That means it's learning the noise in the data, rather than the actual pattern, and won't predict new data well. My goal is to improve the model's ability to generalize to unseen data. The RBF kernel's formula is k, x_I, x_j, equals express, gamma asterisk, x_I, x_j, squared. This measures similarity between data points x_I and x_j, using a parameter gamma. I can improve the model by decreasing gamma. A smaller gamma makes the kernel less sensitive to small input changes. This creates a smoother, less complex model that generalizes better to new, unseen data because it's less likely to fit noise. It reduces the model's tendency to overfit. I can add a noise component to the kernel. Adding this explicitly accounts for data noise in the model. This stops it from overfitting the noise and improves how well the model generalizes. I can switch to a simpler kernel, like a linear kernel. The linear kernel is less complex than an RBF kernel, making it less likely to overfit the data. This is a completely different approach, changing how the model deals with the data relationships. The solution involves making the model simpler. A smaller length scale parameter, gamma, in the RBF kernel, leads to a less complex model, improving generalization by reducing the influence of individual data points. I should not increase gamma, because a larger gamma increases the model's complexity, making it more likely to overfit the training data. It will be even worse than what I already have. Here, I'm investigating ways to modify the radial basis function, RBF, kernel in my Gaussian process regression, GPR, model to reduce overfitting. I need to find the change that reduces the model's complexity and improves its generalization ability. This refers to the data used to train the Gaussian process regression model. The model's performance and its tendency to overfit are directly impacted by the characteristics of the input data. Getting this right is crucial. This equation describes the radial basis function, RBF, kernel. It calculates a similarity score between two data points, x and x. The score depends on the distance between the points and a parameter, gamma. A smaller distance results in a higher similarity score. Controls how quickly the similarity decreases with distance. A larger means similarity drops off rapidly, making the model focus more on local patterns. I would avoid this. Increasing gamma makes the RBF kernel sensitive to small changes. The model becomes too complex, focusing heavily on individual data points. This leads to overfitting and poor generalization on new data. It's like trying to memorize every detail instead of understanding the big picture. I recommend this. Decreasing gamma makes the RBF kernel less sensitive to minor variations. The model becomes smoother, focusing on broader trends, resulting in better generalization. It's like zooming out to see the forest instead of getting lost in individual trees. This is a great idea. Adding a noise term explicitly accounts for random fluctuations in the data. This prevents the model from getting bogged down in noise, improving its ability to learn the underlying patterns. It's like acknowledging that some imperfections are just part of the data. I would also consider this. Switching to a simpler kernel like the linear kernel reduces model complexity. Linear kernels often avoid overfitting, especially with high-dimensional data, giving the benefit of simplicity. It's like changing tools to use the right one for the job. We're using Gaussian process regression with a radial basis function, RBF, kernel, which is a fancy way of saying we're using a bell-shaped curve to model the data. The problem is our model is overfitting, meaning it's too closely tied to the training data and won't generalize well to new, unseen data. Think of it like memorizing the answers to a test instead of learning the material. You'll do great on that specific test, but poorly on a similar one. We need to fix that. The Greek letter gamma, controls the reach of our bell curve. A smaller gamma means a wider bell curve, making our model smoother and less sensitive to small variations in the data. It'll generalize better. I recommend this. It's like blurring the details of a photo. You lose some precision, but the overall picture becomes clearer. By explicitly accounting for noise in the data, we make our model more robust. It prevents the model from getting too caught up in the random fluctuations of the data, improving generalization performance. Think of it as adding a safety net. The model won't fall apart if the data is a bit messy. I recommend this too. Switching kernels is like changing the way we model relationships in the data. A linear kernel is much simpler, and thus less prone to overfitting. I also suggest this method. It's a good idea to keep things simple if possible. Increasing gamma makes the bell curve narrower. This would result in a more complex, wiggly model that's very sensitive to minor data variations. It'll overfit even more, making the situation worse. I don't recommend this approach. I think decreasing gamma, is a great idea. Remember, gamma controls how far the influence of each data point reaches. A smaller gamma means each point has less influence, smoothing out the model and preventing it from getting too caught up in the details of the training data. This helps your model generalize better to new, unseen data. That's precisely what we want to avoid overfitting. Adding a noise component is like acknowledging that your data isn't perfect. It's a way of saying, hey model, don't trust the data too much. There's some noise in there, so don't fit it too tightly. By explicitly accounting for noise, you make your model more robust and less likely to overfit the noisy parts of your data. Switching to a simpler kernel, like the linear kernel, is like changing your approach entirely. The RBF kernel, radial basis function kernel, is very flexible and can be prone to overfitting. A linear kernel makes fewer assumptions about the data and is less likely to overfit. It's a simpler model that will likely generalize better. Increasing gamma would be a mistake. A larger gamma makes each data point's influence more localized, increasing the model's complexity and making it much more sensitive to noise. This would likely make overfitting even worse, exactly what you want to avoid. I'm tackling a problem where a Gaussian process regression model, using a radial basis function, RBF, kernel, is overfitting the training data. This means the model is performing too well on the training data but poorly on new, unseen data. The goal is to improve its generalization capability. Sklearn is a popular Python library for machine learning. I'm using its Gaussian process regression, GPR, tool with an RBF kernel to build a predictive model. The RBF kernel uses a length scale parameter, gamma, to determine how sensitive the model is to small changes in the input data. Currently, my model is overfitting, which indicates it's learning noise in the data instead of the underlying patterns. To fix overfitting, I'll decrease gamma. A smaller gamma makes the model less sensitive to minor input variations, resulting in a smoother prediction function. This reduces the model's complexity and prevents it from capturing noisy details, improving its ability to generalize to new data. Think of it like smoothing out a bumpy road, less sensitivity to small bumps. It's a great way to make predictions more robust. Adding a noise component to the RBF kernel explicitly acknowledges the presence of noise in my data. This prevents the model from trying to fit the noise perfectly, leading to improved generalization performance. The model will learn the underlying trends while ignoring the random fluctuations. Switching to a simpler kernel like the linear kernel significantly reduces the model's complexity. The linear kernel makes less assumptions about the data than the RBF kernel, meaning it is less likely to overfit. Increasing gamma would worsen the overfitting. A larger gamma makes the model extremely sensitive to even small changes in the inputs, allowing it to fit the training data too closely, including the noise. This would lead to a very complex model that doesn't generalize well.